In the previous video, we looked at another way of detecting for errors, which is called echo check. And we said echo check, it is a way of checking for errors that uses a method of sending a message to the receiving person. Then the receiving person will have to send back the message to the sending person. And then now that the sending person will devise now has got the two messages, the one that was sent to the receiving and then the one it received from the receiving. Then if those two messages match, then no errors will have been introduced. But if they don't match, it means there were errors introduced during the process of transmission. Then the message will have to be transmitted again up until no errors, up until the sending device reads no errors. Welcome to my channel, Kuda Entertainment TV, where we focus on computer science, ICT, and mathematics with your host, Say Kuda. So today we are going to look at another way of detecting for errors, which is called automatic repeat request, or abbreviated as ARQ. So ARQ is a method of detecting for errors which involves the use of acknowledgement and timeout to check if there were errors or no errors in the process of transmitting data. So this is ARQ, right? So when an error has been detected after the data has been transmitted, it means the message will have to be retransmitted again, right? The message will have to be retransmitted again. Let me give you a very good example. In a wartime situation, right, the importance or the accuracy of data in fact is of utmost importance, right? The accuracy of data. Why? Because if you keep on piling, the receiving person with wrong information, it can lead to many losses and fatalities. So the accuracy is of utmost importance. So now let us look at the two approaches that we can use to implement automatic repeat request. Right, so the first one is called a positive acknowledgement. That's the first one. It is called the positive acknowledgement. So in a positive acknowledgement, a bit of data or a packet of data is sent to the receiving device. And remember, when we started chapter 2, we said before the data is transmitted, it is broken down into small units which we refer to as data packets. So when this data packet is received by the receiving device, it then checks, that's step number 2, it checks for errors, right? It checks for errors. And then if there are no errors, step number 3, if there are no errors, it sends a positive acknowledgement to the sending device. Then when the sending device receives this positive acknowledgement, it now knows that there were no errors that were introduced in the transmission of a data packet. Then it goes on to transmit the next data packet, right? And let's say after a certain timeout, right? Remember we said it uses timeout and acknowledgement. Let's say after a timeout of let's say 20 minutes, then there was no any positive acknowledgement received from the receiving device, then the sending device automatically knows that there were errors, right? It knows that there were errors that were introduced, and then that data packet will have to be retransmitted again. It will have to be retransmitted again. So that is positive acknowledgement, right? Now up until, so this is repeated up until all the data packets are fully transmitted. So let us now look at the second approach of implementing this, which is a negative acknowledgement. So the second approach to ARQ is known as the negative acknowledgement. So in a negative acknowledgement, a data packet is sent to the receiving device. Then the receiving device will receive this data packet and then check for errors, right? It checks for errors. If there are no errors in this packet of data, then no further action is taken. But if there are errors, then it sends a negative acknowledgement to the sending device. So once a sending device receives this negative acknowledgement, it now knows that the data was transmitted incorrectly, and then that data packet will be transmitted again to the receiving device, right? It will be transmitted again to the receiving device. And then let's say after a set timeout, maybe let's say it's 20 seconds, and then the sending device does not receive any the negative acknowledgement from the receiving device, it also knows that no errors were introduced during the process of transmission. Then it will go on to transmit the next data packet. And mind you, in all these two approaches, the timeout is set by the sending device. That's the one that says the timeout. The sending device is the only one that is responsible for setting out this timeout. So these are the two approaches that we can use in transmitting, in detecting for errors using automatic repeat request. Thank you very much for watching my videos. Please consider subscribing to my channel. Also follow me on my Facebook, LinkedIn, using the links provided in the video description below. Also like and share. Please, that's the most important thing. Please share my videos so that the algorithm will be able to pick up my videos and recommend them to many users. So thank you very much. And also consider donating to my channel. This will go a long way in making me continue giving you more and more videos, and also improving the quality of my presentations. Thank you very much. See you in the next video. Stay blessed.